last video, you were introduced to a problem about calculating odds ratio. So far, we have filled out how many of our smokers develop lung cancer and how many of our non-smokers develop lung cancer. We also went ahead and filled out our total exposed versus total unexposed. In order to calculate odds ratio, we do not use totals, and that's the most important thing to remember. I don't use this 150 number at all. I'm using everything that is inside my boxes. So 150 minus 50 gives me 100. If I know there's 150 total and only 50 of them developed lung cancer, then the other 100 did not. Similarly, I will do 150 minus 22, and I will get 128 for this box here. Now all I have to do is follow my formula. So I'm going to do 50 divided by 100 over 22 divided by 128. Just remember when you're plugging this into your calculator to put parentheses around the 22 divided by 128 so none of your numbers get messed up. At this point, you can go ahead and pause the video so you can do this calculation if you haven't already and see what number you get. And so I got an odds ratio of 2.91. Now, keep in mind that I did make up these numbers and that this isn't data that you could then go apply or tell a patient or anything like that, but this is just a number that I used for example's sake. So my odds ratio is 2.91. Now, interpreting this odds ratio is pretty similar to what we talked about in another video about interpreting risk ratio. Only you want to be careful with using the word risk when you're actually calculating an odds ratio. So what I would say is that the odds of developing lung cancer is 2.9 times So how would I interpret this? So I would say that the odds of developing lung cancer in smokers is 2 times the odds of developing lung cancer in non-smokers. So if I actually came across a study that had this odds ratio of 2.91, I just have to be careful to use the word odds. Now remember in the previous video, we said that with cohort studies, you can calculate both a risk ratio and an odds ratio because you are starting with the exposed and unexposed. So in other words, you're starting with patients who do not have the outcome. And so you could actually calculate the risk of developing the outcome. And in this case, we could have done a risk ratio as well. And as you know, your risk ratio would be as simple as remembering your formula of the experimental event rate divided by the control event rate. And you might be wondering, well, what's the experimental and what's the control? I'm not actually giving an intervention. So what it would be is your experimental in this case would be like your patients that were exposed to smoking. So that would be the 50 divided by 150. So out of 150 patients, 50 develop lung cancer divided by 22 over 150. And so that way you would go ahead and calculate your risk ratio.